So, hello guys. So let's begin with the problem cherry pickup 2. So let's start with the problem statement. So you are given a rows into column matrix grid and representing a field of cherries where grid ij represent the number of cherries that you can collect from I comma j cell. Okay, so as you see in the example 1, like this is the grid given to us and these values are representing the number of cherries. Okay, so you have two robots that can collect cherries for you. As you see here, two robots are there. First robot is located on the top left corner, so it is located on the top left corner, and the second robot is the top right corner here. Okay, and return the maximum number of cherries collection using both robots by following the rules. Okay, so what is the rule? So rule is that robot can move to the cell I plus one j minus one I plus one j. Okay. So the rule is that, and when any robot pass through a cell, it picks up all cherries, and the cell becomes an empty cell. When both robots stay in the same cell, only one take the cherries. Okay, both robots cannot move outside of the grid and both robots should reach the bottom of the grid. Okay, so basically there if the robot one is standing here, so there are three paths. Like it cannot go in this path here, but it can go to this grid and to this grid. Okay, similarly for the robot 2 also there are three possible paths. Here this path is blocked because it is outside the grid. Okay okay so what to do in this problem? So if I like, what is the brute force approach? Like if you observe it, like it's coming something like possible paths, like one is here, another one is here, and again this one. So robot one have three choices to go, how to go in the lower, in his below column, in his below row. Similarly for the robot two also, so 3 into 3, so there are total 9 possible ways to go in the below grid and to pick up. So pick up, how to pick up so that it maximize the total return of both the robot 1 and 2. So if you are thinking to solve this by just calculating, by just going one by one, for the robot 1 just calculate it separately, and for a robot 2 calculate it separately, but it will give you a wrong, because we have to maximize the summation of both maximize we need to do. So if I talk about, like, the problem is looking like we have to find the maximum and there are possible ways to go. So again possibilities are coming into the picture and I have to maximize. So again this problem is belongs to a TP. So before going to the TP, first let's see how to write the recursive solution for this. So okay, so first thing, there are total 9 possible ways. Okay, and the second case is that, let's say if my robot 1 will reach to this grid and robot 2 is at the same time reach to this grid, then in my answer I can only add this 5 only once time. But if my robot 1 is here and the robot 2 is here, then I can add 2 plus 5 7 to my answer. So that in this way I have to maximize it. Okay, so basically, if you are getting this problem, how to write a recursion, like this problem is belongs to recursion. And like, what is recursion? Whatever the possible ways you should write, you should call the recursive function for those ways, and at the last you will get your answer. Okay, let's try to understand by writing the code. Okay, so first of all I am going to write the helper function. So helper function, now I need this grid, control plus C, now control plus P. Okay, int. Okay, so what are the possible DP states? So for the robot 1, I1 and J1, and for the robot 2, I2 and J2. But again, 4 DP states are there. But if you observe it carefully, like I1 and I2, like after the next operation, both the robot will be always in the same row, because they both are moving together. Both the robot have to move in their below grids. So that's why always the row number is same, but the column is different. So instead of making four variables, four DP state, three DP states are enough to solve this problem. So row column one and int column two. Okay. Now I need to each time. Okay. Okay. Write first int n and m. So let me grid dot size and m equals to grid 0 dot size. Okay. Now what is the base condition? Base condition when the row and columns are in the scope or not. So for that I'm going to write a check function to check. So I int j int n int m and just return I greater than equals to 0 and I lesser than n, j greater than equals to 0 and j lesser than m. That's all. Okay, so now check whether the grid is valid or not. So okay, so how to check? So inside this, just call the check function and pass the row column 1 n m. Or why? Or because if any of the robot is out of the grid, then we return at the same time. I'm going to terminate my recursion. Okay, so row column 1 and column 2, sorry, column 2, only column 2 nm and directly return 0. Okay, so I talk about the 9 possible ways. So what are those ways? So for column, like my row will always going to row plus 1, but how the column will change? Column will be changed from minus 1 to 1, minus 1, 0 and 1. Okay, so I equals to minus 1 and I lesser than 2 and I plus plus. Similarly for j equals to minus 1, j lesser than 2 and j plus plus. So now first here check, row is always same, but if column 1 is equals to column 2, so at that time we just need to count that grid value only once. Okay, so I have to store this all the possible 9 ways, the answer of all the possible 9 ways in one variable, and I have to take the maximum, and each time I will return the maximum. So int answer equals to 0, and this variable, in this variable I'm going to count the maximum maximum of answer, comma, just call the helper function. Okay, so here the column and column 1 column 2 is same, so I will just add only one time and then call the helper function. Great. Now my row is become row plus 1 and column 1 is plus I and column 2 is plus j. Similarly, if column 1 and column 2 is not equal, then again I will do the same thing, but this time I will add, before calling to the helper function, I will also add great row column 2. At the last, directly return the answer. Now just call the recursive function helper great, and row is 0 initially, column 1 is also 0 and column 2 is grade 0 dot size minus 1. Now let me run it. So this is the recursive solution. As you see, the sample test cases are passing here. So now I've shown in my videos before also, like how to convert a recursive solution into a DP by memoizing it by just adding 3 to 4 lines. So I am going to do the same thing here. So as we know, the rows and the column, the maximum value is 17. So I can take 71. So TP is, so this is the declaration of the DP variable to memorize my recursive solution, because as we know there are three DP states: row, column 1 and column 2. Now here just assign with -1. This is to assign with -1. So size of DP. Now the third step, here where we are returning first store row, column, column 2. Okay, and like, so we are storing it. So for calculating, first check whether this value is already calculated. If it is already calculated, it means that it is not -1. Then return. So let me run it. Okay, so it's running fine. Let me submit it. So as you can see, the solution is accepted. So that's all for this problem.